this section, we'll be factoring binomials, differences of two perfect squares, or differences or sums of two perfect cubes. Let's go back to multiplying, where the result is a difference of two perfect squares, so that we can see the pattern as to how to factor. Notice same numbers with opposite signs in the binomials. This is the case where the result is a difference of two perfect squares. Recall our goal, that is, to be able to factor. We need to be able to recognize the difference of two perfect squares and then factor it. Here states the definition. Understand the differences of two squares are factorable, but not sums of two perfect squares. Since this is a difference of two perfect squares, we know that we need opposite signs in the binomials, square root of 25y squared for the first position and square root of 9 for the second. If necessary, you can FOIL to check. Start with the greatest common factor and then look closely at the binomial factor. It is again a difference of two perfect squares. Even exponents on variables are always perfect squares. Recall only differences, not sums of squares are factorable. We finish by factoring the factor that is a difference of two perfect squares. Now we move on to factor a sum or difference of two perfect cubes. If a number is a perfect cube, you can come up with a number that, when multiplied by itself 3 times, results in that number. Let's first focus on the sign pattern in the binomial and trinomial. I like to chant same, opposite, and positive to help sort out the signs. The sign of the binomial is the same as in the difference or sum of the two cubes. Then it goes opposite and positive. Let's multiply so we can see what kinds of factors multiply to a sum or difference of two perfect cubes. We distribute the x, then the -2 to the 3 terms inside the second set of parentheses, and then collect like terms. Our first goal is to figure out what can be cubed for the first term and the last term. For example, x can be cubed for x cubed, 2 can be cubed for 8. The a and the b are the one of these 3 same factors. Here we have the sum of 2 cubes, since you can come up with a number, cube it, and get those 2 numbers back. A sum or difference of 2 cubes is always factorable. Factors into a binomial times a trinomial. Let's first sort out the sign pattern. Recall, same, opposite, and positive. Here we have the sum of 2 cubes, since you can come up with a number, cube it, and get these numbers back. Let's first, again, sort out the sign pattern. Same, opposite, and positive. The sign pattern will be the same, opposite, and then again, n plus. What goes in the binomial factor are one of these 3 same numbers that multiply for the 125a to the 6th and the 27b cubed. Notice the first position of the trinomial is a squared and the last is b squared. In the middle, we place the product of a and b. This completes the factoring of the sum or difference of two perfect cubes, and hopefully it's been helpful.